All right, last two questions for the law of cosines worksheets. Problem number 9. Ship A is 30 miles due east of ship B. All right. So let's see what we've got here. I want to draw somewhat of a picture for this. All right, so ship, I'm also trying to see if this is... All right, so we're going to go ship A. Nope, wrong ship. All right, ship B is right here. And we're going to say 80 miles east. Okay, ship A is 80 miles east due 80 miles due east of ship B. Captain's pickup is stress signal from ship C. One of the ships needs to go rescue ship C. Ship A picks up the signal from 80 degrees west of north. So from ship A, we're going to go north and then push it 80 degrees to the west. So this is going to look a little bit weird, and let's zoom in here. So if I'm at north here, I want to push 80 degrees to the west. Okay, which ultimately means that there would only be 10 degrees left over to be completely to the west, and can travel 20 miles per hour. All right, ship B picks up the signal from 70 degrees east of north. So ship B here, if we go to the north, we're going to push 70 degrees to the east. All right, so there's going to be 70 degrees here, which means 20 degrees left over. Now, ultimately, when I connect these pieces together, that's where ship C is sitting, okay? We know we have a 20-degree angle. We know we have a 10-degree angle. So this angle right here would be 150 degrees. Total of 180 for the three angles of a triangle. How long would it take each ship to reach ship C, and which ship should rescue ship C? All right, so we're actually going to figure out, let's say this is little b over here, this is little a over here. Now that I look at this problem, this is actually a law of sines problem, because we don't know enough of the sides to figure out law of cosine. So I'm going to go ahead and keep answering this question. But just know, based off of this information, this is a law of sines problem. Now, we're going to do law of sines twice. We're going to do it once to solve for A and once to solve for B. So let's say for A, let's see here. We're going to do sine of 10 over A is equal to sine of 150 over 80. To solve for A, this would be 80. Hold on 1 second. I think I screwed that up. No, I didn't. 80 sine of 10 divided by sine of 150. So A is equal to, so that goes into the calculator. 80 sine of 10. Take that answer divided by sine of 150. So A is 27.78 and some more stuff here. Now, ship A can travel 21 miles per hour. So if ship A is 27.78 miles away, or whatever this is, I'm going to divide by that 21 miles per hour that it can travel. And ship A would take 1.32, let's get a 2 there, 2 hours to reach the ship C. Separately, all right, I'm going to go ahead and divide this up here. Separately, I'm going to find part or B here. And actually, I just goofed that up. The distance, the little distance A here is actually the distance from ship B to ship C. So I want to just fix that. So that would be ship B here. All right. So I am going to find a little b over here, which will be the distance for ship A to ship C. Again, you could mark these with whatever variables make sense to you so you don't make that mistake that I just made. So let's see. Sine of 20 over b is equal to sine of 150 over 80. So b is equal to 80 sine of 20 over sine of 150. All right, so go ahead and throw that into a calculator or technology of your choice. All right, so ship B is 54.72 and some other decimals away. And ship B can travel at 14 miles per hour. So divide by 14. So, I am goofing this up all kinds of ways. Okay. Ship B was distance A away. Ship A is distance B away. I got the right distances, but I'm dividing by the wrong speeds. So I got to fix this. So let's go over here, ship B. This is the one I got most recently in my calculator, or distance B. Distance B is ship A to ship C. Ship A can travel 21 miles per hour. So I'm going to take this distance, this distance, divide by 21. All right, so ship A would take 2.6 hours. Technically, it's 2.61 hours. I'll get real specific. Okay. Distance A, this would definitely be a good reason not to use A and B. I thought I was being creative and, helpful for myself, and I was not. So ship A, distance A, which is ship B, is 27.78. I've got that in my calculator. Let me make sure. All right. I thought I had it in my calculator. It ran away. So let's try this again. All right, so 80 sine 10 divided by sine of 150. Okay, so I've got that in my calculator. Now I'm going to divide by, so distance A is from ship B, and ship B can travel 14 miles per hour. Okay, so ship B would take 1.98 hours. All right, determine how long it would take each ship to reach ship C. We've got that. Took me a little while, but I got there eventually. Which ship should rescue ship C? That would be ship B. They can get there. Even though they're moving slower, they've got less of a distance to travel, so therefore it would be a better bet for them to get there on time. All right, let's see if I can get through problem number 10 without making that many horrible mistakes. Sorry about that. All right, sides of a triangle are 6, 9, and 11. All right, draw yourself a little triangle. 6, 9, 11. If theta is the measure of the smallest angle, smallest side, smallest angle is across from it. Determine the exact value of sine of theta. Now, you've seen us do, we did a problem where it was the exact value of cosine. You did the exact value of tangent. Exact value of sine is pretty much like exact value of tangent. All right. So we've got to set up law of cosines, because even though we're asked for a sine answer here, we do not have enough information to do law of sines. So you absolutely have to start with law of cosines here. So 6 squared is equal to 9 squared plus 11 squared minus 2 times 9 times 11 cosine of theta. Do a little solving here. We're going to go ahead and take 6 squared minus 9 squared minus 11 squared. So minus 9 squared minus 11 squared. Negative 166. I'm going to go ahead and multiply this out. Negative 2 times 9 times 11 is negative 198. I don't know why I started to write that. So cosine of theta, divide by 198 on both sides. That is negative. So negative 166 divided by negative 198. Turn it into an exact fraction. Oh, this is not going to be terribly pretty, but that's okay. All right, so now I've got the exact value of cosine of theta. I want sine of theta, so I'm going to go ahead and transition this to a right triangle. Label theta wherever. Cosine, remember, is adjacent over hypotenuse. So using what I know about Pythagorean theorem, I'm going to solve for that a value. So a squared equals, nope, get the right, a squared plus 83 squared equals 99 squared. So if I take 99 squared minus 83 squared, I'm going to get a not too pretty number here. 2,912. I need to take the square root of both sides. I'm going to guess that that's not a perfect square. I guessed correctly. Let's see. I'm just doing some quick check here to see how many times I can simplify this. Actually, you know what? For our purposes for this problem, I'm going to go ahead and leave it, just let it be the square root of 2,912. If your calculator can do a square root easily, go ahead and do that. If not, I'm not going to worry about it as being something very special to this problem. If it was something easier like square root of 20, I would expect you to simplify it. Square root of 2,000 and change, not so much. So the sine of theta is going to be the opposite side, so the square root of 2,912 over the hypotenuse of 99. All right, not the easiest numbers to work with, and of course problem number 9, I just kept goofing up which parts were which parts. So if I have confused you, my apologies, and if I have confused you in any way, shape, or form, please ask questions that I can help